Right, so section 3.2 is on dividing polynomials. Okay? And so we're going to learn how to divide two polynomial functions using long division. And I'm guessing that most of you had learned long division in grade school, right? How to divide two whole numbers, right? Using long division. So let's review that. And there's the last page of your handout is blank, so what I'm about to put on the board, right, on the last page. So the fraction 137 thirds, right, we know is called an improper fraction. Fractions between 0 and 1, right, are called proper fractions. Fractions greater than 1 are called improper fractions. And I've been saying all semester long, right, fraction bars are like division symbols. You can read this as 137 divided by 3, right? So let's divide 137 by 3 using long division. What goes under the division symbol, right, is the numerator, and what goes to the left of the division symbol, right, is the denominator. We call this under the division symbol the dividend, and the 3 is the divisor. Now there's an algorithm for dividing two real numbers, two whole numbers, using long division. And the algorithm has 3 mathematical operations in this order. Okay? We divide, and we multiply, and then we subtract. And we perform those 3 mathematical operations in that order until we're done. So first, right, we start with the first digit in the dividend. 3 goes into 1, and when we do this division, right, what's the whole number of times that the divisor goes into the number? Well, 3 goes into 1, 0 whole times. So now we get to the first 2 digits. 3 goes into 13, 4 whole times. Right, so that's the division. And now we multiply. 4 times 3 is 12. Write that under the 13 and the dividend. And then now we subtract 12 from 13, and we get 1. So we divide, multiply, subtract. We just keep doing that until we're done. Now we bring down the 7. 3 goes into 17 5 whole times. We write that up there next to the 4. Now we do the multiply. 5 times 3 is 15. And now we subtract 15 from 17, and we get 2. So the 45 is called the quotient in our long division. And the 2, right, is called the remainder. So 137 thirds is equal to the quotient 45 plus 2/3. Okay? The remainder divided by the divisor. And in high school, you might have written this sum as a mixed number, right? 45 and 2/3. But we don't do much with mixed numbers at the college, university. For proper fractions. All right. Now, if I multiply both sides of this equation by 3, I have 137 is equal to 3 times 45 plus 2. Okay. If I multiply both sides of this equation by 3. Right? I have 137 is equal to 3 times 45 plus 2. So the dividend is equal to the divisor times the quotient plus the remainder. Okay. So that is basically what all this is up here with real numbers. Okay. Any questions on that review? Well, just as we can divide two whole numbers, we can divide two polynomial functions. And so we'll demonstrate that with example 1. We'll start with A, the first one. So we have 6x cubed minus 19x squared plus 16x minus 4 over x minus 2. Remember, fraction bars are like division symbols. So this can be read as this third degree polynomial divided by this first degree polynomial. The numerator divided by the denominator. So the numerator is the dividend, and the denominator is the divisor. And so we do the setup just like we do with real numbers. The dividend goes under the long division symbol. The divisor goes out of here to the left. Now, when you set this up, you got to make sure the dividend is in descending powers of x and the divisor is in descending powers of x. Okay. In order to do this properly. And we're going to just follow our algorithm from real numbers. We're going to divide, multiply, subtract. Divide, multiply, subtract until we're done. Okay? We're going to be working with the largest power of x in the divisor, okay? And then the largest power of x in the dividend, okay? So the largest power of x in the divisor is x, and the largest power of x in the dividend is 6x cubed, right? So the first question is, okay, just as we asked how many times does 3 go into 13, we're asking how many times does x go into 6x cubed. Okay, that's the divide. So to do that, right, you set it up as a fraction. 6x cubed divided by x. Okay? 6x cubed divided by x. And using the rules of exponents, that simplifies to 6x squared. So x goes into 6x cubed, 6x squared times. That's the divide. Now the multiply, okay, and so now, okay, that 6x squared goes up here above the long division symbol, okay, above the x squared term in the dividend. And now we do the multiply. We multiply 6x squared times x minus 2. And when you distribute the 6x squared, you have 6x cubed minus 12x squared. That's the multiply. And now you write that under the dividend. 6x cubed minus 12x squared. And now we do the subtraction. We subtract this from the dividend. Put this in parentheses, and a minus sign up. So you got to distribute the minus sign correctly. So when you distribute the minus sign, you have minus 6x cubed plus 6x cubed, which is 0. So the first column should go away if you do this correctly. Then minus 12x squared becomes plus 12x squared, and 12x squared minus 19x squared is minus 7x squared. Okay. And now we bring down these remaining terms in our original dividend. And now we have a new dividend. Minus 7x squared plus 16x minus 4. And now you got to ask yourself, how many times in our divisor, x, how many times does x go into minus 7x squared? So you write it out as a fraction. Minus 7x squared divided by x. And by the rules of exponents, that simplifies to minus 7x. So now you write minus 7x of the x term, okay, in our original dividend. And now you got to do the multiply. You got to do minus 7x times the divisor, x minus 2. Now you just distribute the minus 7x inside the parentheses. You have minus 7x squared plus 14x. That's the multiply. And now you subtract the minus 7x squared plus 14x from our new dividend. So minus that, what's in parentheses. And this minus sign is going to change the sign of those two terms, right? So minus 7x squared becomes plus 7x squared, and 7x squared minus 7x squared is 0. The first column goes away, like it's supposed to. Plus 14x becomes minus 14x. 16x minus 14x is 2x. So this is now our new dividend, okay? And now you gotta ask yourself, how many times does x go into 2x, right? Well, 2x divided by x is 2, right? So that's the divide. And now we multiply 2, right? So we put plus 2 above the minus 4, the original dividend. And now we multiply 2 by the divisor. And we get 2x minus 4. So that's the multiply. So we put 2x minus 4 down here. We subtract it from the 2x minus 4 above, and we get 0. So the remainder from our long division is 0. So what have we learned? Well, this quotient is equal to our quotient from the long division. It's equal to 6x squared minus 7x plus 2. And now if I multiply both sides by the divisor, x minus 2, we have our 30-degree polynomial is equal to the divisor, x minus 2, times the quotient from the long division. So x minus 2 is a factor of this third degree polynomial, and this quadratic is a factor of that third degree. It's important that you understand this, because in the next section, we are going to be factoring polynomial functions, and sometimes you got to do long division to get all the factors. Okay. Remember, doing what's called the complete factorization. And sometimes you got to do long division to get all the factors. Okay. So it's an important skill to have. Okay. All right. Any questions on this, ladies and gentlemen? All right, so let's move on to the next one. We have 2x to the 5th plus 4x cubed minus 5x squared plus 3x minus 2 all over x squared minus 3. Sorry, we're dividing the numerator by the denominator. Okay. The numerator is the dividend, the denominator is the divisor. And everything, both the numerator and denominator are in descending powers of that. So like before, we put the numerator under the long division symbol. The divisor goes out here to the left. All right, so again, right, we're doing the same steps. Divide, multiply, subtract, over and over again. So first step, how many times is x squared going to 2x to the 5th? 2x to the 3rd. So we put 2x to the 3rd above this term in the dividend. And now we do the multiplication. 2x to the 3rd times the divisor, x squared minus 3. And when we distribute 2x cubed, we get 2x to the 5th minus 6x cubed. So you notice that I'm getting away with something, right? I should have left a space for x to the 4th. In most instances you would, okay? But I'm going to get away with not having it in this problem. So we have 2x to the 5th minus 6x cubed. Usually, if you're missing a power of x, right? So in this polynomial, the coefficient in front of x to the 4th is 0, okay? 0 times x to the 4th is 0. And so I got away with not, I'm getting away with that. I should have left a space here for the x to the 4th term, okay? But I don't need it today. Yes, sir.
Does it change like the answer or anything?
If what?
If you do forget it, does it like change the answer?
It can't. Yeah. But I'm not going to have a x to the 4th term in my answer, so I'm getting away with it. All right, so now we subtract 2x to the 5th minus 6x cubed from the original dividend. So when I distribute the minus sign, I'll have 2x to the fifth minus 2x to the fifth, which is 0, which is, you better have that. Minus 6x cubed becomes plus 6x cubed. 6x cubed plus 4x cubed is 10x cubed. Now I bring down the remaining terms of the original dividends. Now I have a new dividend. Okay. Now I got to ask myself, how many times is x squared going to 10x cubed? Well, x squared goes into 10x cubed 10x times. So I write it over here above the 3x in the original dividend. And now I multiply 10x by the divisor, x squared minus 3. And when I distribute the 10x, I have 10x cubed minus 30x. So now I subtract 10x cubed minus 30x from my new dividend. When I distribute the minus sign, I have 10x cubed minus 10x cubed, which is 0. Minus 5x squared minus 0, which is minus 5x squared. And then we have 3x plus 30x, which is 33x. And then we bring down the minus 2. So now this is my new dividend. And now I have to ask, how many times does x squared go into minus 5x? Well, it goes, x squared goes into minus 5x squared minus 5 times. So I put minus 5 above the minus 2 in the original dividend. Now I multiply minus 5 times the divisor. And when I distribute the minus 5, I have minus 5x squared plus 15. And now I subtract minus 5x squared plus 15 from the new dividend. And when I distribute the minus sign, I have minus 5x squared plus 5x squared, which is 0. I have 33x minus 0, which is 33x. And minus 2 minus 15, which is minus 7. And x squared goes into x 0 times. Is a whole number. So this is our remainder. So our original quotient, numerator divided by denominator, okay, can be written as the quotient from our long division, 2x cubed plus 10x minus 5, plus the remainder divided by the divisor, 33x minus 17 over x squared minus 3. Okay, so this is equal to this, okay? Now, if if I multiply both sides of our equation by the divisor, x squared minus 3, we have our fifth degree polynomial, 2x to the fifth plus 4x cubed minus 5x squared plus 3x minus 2 is equal to the divisor, x squared minus 3 times the quotient from our long division, 2x cubed plus 10x minus 5 plus the remainder from our long division. Any questions on long division of polynomials? Yes, ma'am.
So like for answers, would you want us to write the one on the left or the one on the right?
When it comes to WebAssign, I guess it's going to be what they request. Okay.
But like
Yeah.
on test?
On test, then I'll probably leave a space for what's the divisor, what's the quotient, what's the remainder type thing. I won't necessarily maybe have you write it out like that or like that. Right. I have you do the long division, and then you tell me what the parts are. All right. So any questions on that, ladies and gentlemen? So you'll get some practice, right? I think there's 3 problems on the homework, the website homework, to give you long division. All right. So you flip over the page. And we have what is called the remainder theorem. And there's, I think I fixed it in this version. Okay. My old notes, there was a typo, but it looks like I remembered to fix it. Okay. So let's review the remainder theorem. Okay. If a polynomial is divided by x minus c, which is called a linear polynomial because it's x to the first power, then the remainder is the value of the polynomial at x equals c. Okay? So if you're going to divide a polynomial function by x minus c, where c is some real number, you don't have to perform the long division to find out what the value of the remainder is. You just evaluate the function at x equals c, and now you know what the numerical value of the remainder is. So you can do that without actually performing the long division. Okay? So let's just make a note. Don't have to do long division to find the remainder. Okay. So let's demonstrate that with an example. Example 3, use the remainder theorem to find r. Right? then we have to find the remainder r when f of x is divided by x minus 3. Okay? So x minus c in this case is equal to x minus 3. So you do the arithmetic, you do the algebra, c is just equal to 3. You can also see the by expansion. Okay? So to find the remainder, okay, when f of x is divided by x minus 3, we just evaluate f of x at x equals 3. So when we plug in 3 in for x, we have 2 times 3 cubed minus 5 times 3 squared plus 4 times 3 minus 6. And so when you do the order of operations, you get 15. So if you divide this polynomial function, this third degree polynomial, by x minus 3, okay, the remainder will equal 15. R will equal 15. Okay. You don't know the quotient, okay, but you know what the remainder is. Okay. Example 4 says use the remainder theorem to find f of c for f of x when c equals 1/2. So what that's basically saying, if you divide f of x by x minus 1/2, okay, c is equal to 1/2, then the remainder from that division is equal to f of 1/2. And what's f of 1/2? It's equal to, right, you just put in 1/2 in for x and f of x, and when you do that, you get 3 times 1/2 to the 4th minus 5 times 1/2 squared plus 2. Now you got fractions. 1/2 to the 4th is 1/16. 1/2 squared is 1/4 plus 2. I'll leave it to you to verify that that simplifies to 15/16. Okay. All right, synthetic division. How many of you were exposed to synthetic division in high school? Raise your hand. Yeah, most of you, right? So synthetic division is a convenient method for dividing a polynomial function by a linear polynomial x minus c. Okay? It only works when you have x to the first power in your device. Okay? Can't do it if you have x squared or x cubed or x to the 4th, right? It has to be x to the first power minus a real number, okay? So let's flip over to page 3 and demonstrate how to use synthetic division. So we're going to divide x to the 4th minus 14x squared plus 5x minus 9 by the linear polynomial x plus 4. Okay. We're not going to do long division, right? We're going to do synthetic division. Okay. Now, the divisor x minus c is equal to x plus 4. Solve for c, is c is equal to minus 4. So when you do the synthetic division, you gotta change the sign of the number, okay, in the divisor. Alright. Step number 1 is you put -4, the value of C, in a box on the left, okay? And then step number 2 is you write out the coefficients of the polynomial in the numerator in descending powers of x. So the coefficient in front of x to the 4th is 1. Now you notice that there's no x cubed term, right? So the coefficient in front of the x cubed term is 0, right? 0 times x cubed is 0. That's why you don't see an x cubed here. The coefficient in front of the x squared is -14. And the coefficient in front of the x is 5. And then the constant term is -9. You leave a space for numbers, right? A row, an empty row for numbers. And so this is the algorithm. Step number 1, bring down this number, right? So we bring down the 1. And then we multiply by the value of C, which is -4. So -4 times 1 is -4. And then we put it in the next column. And then you add those two numbers. So 0 plus -4 is -4. And now we go back here to step 2. We multiply this number by -4, and we get 16. And now we add 16 to -14, we get 2. Now we multiply -4 and 2, we get -8. Now we add 5 to -8, and get -3. Now we multiply -3 by -4, and we get 12. Now I'm going to put it in this last column. I'm going to put a box in the last column, right? The last position in the last row, because that's where the remainder goes. -9 plus 12 is equal to 3. So 3 is the remainder R. Okay? Now, to get the quotient, right, from this division, you start, right, our quotient has 4 terms in it. You start from the right. This number here is the constant term in our quotient. It's x to the 0, which is equal to 1. This number here is the coefficient that goes with x. This number here is the coefficient that goes with x squared. And this number here is the coefficient that goes with x cubed. Okay? We're dividing a 4th degree polynomial by a linear polynomial. X to the 4th divided by x is x cubed. So our quotient, when we're done, is going to be a 3rd degree polynomial. So to get the quotient, which we call q of x, we multiply the coefficient times its x term. So 1 times x cubed is x cubed. -4 times x squared is -4x squared. And 2 times x is 2x, and then minus 3 times 1 is minus 3. So our quotient from the synthetic division is this third degree polynomial, and our remainder is plus 3. Okay. So we can write x to the 4th plus 14x squared minus, x to the 4th minus 14x squared plus 5x minus 9 over the divisor x plus 4 is equal to the quotient x cubed minus 4x squared plus 2x minus 3 plus the remainder 3 divided by the divisor x plus 4. And if we multiply both sides by x plus 4, we have the 4th degree polynomial is equal to the divisor x plus 4 times the quotient plus the remainder 3. Okay. Now, for those of you who haven't been exposed to synthetic division, I'm taping this lecture, recording this lecture. And it'll be posted, right? The link will be posted on Oaks. So you need a review, right? You're not sure how to do synthetic division, you go back and rewatch this problem. Okay. Some of you had synthetic division in high school, right? You probably were ahead of me in solving this problem. But this is the first time you're seeing synthetic division, right? Don't stress. You can review what we did today. Any questions on this? For those of you who had in high school, it's like deja vu. Huh? Seen this somewhere? All right, so let's stop right here. I want to give you plenty of time to take the quiz. Okay, we'll probably be done in 3 minutes, but I want to give you plenty of time. Okay. And we'll do the last problem tomorrow.